This is my MPCNC project. I'm just starting it. I've printed most of the parts, which are on the table here. There's a couple more large parts to print, and whilst they're printing at the moment, I'm going to start putting it together. So the first task is to cut the stainless steel tubing. I've purchased 25mm stainless steel tubing, 2mm thick. If you want to save yourself a lot of time, buy a cheap pipe cutter, which is what I've done. That's that one done there. It should last long enough to cut all the pipes to size. So I've started cutting the pipes. Here goes. Make sure you measure carefully the lengths. You can use the calculator. Just look up MPCNC calculator to work out the lengths of the tubes that you need for the size of MPCNC machine you're going to make. I'm making a 300mm MPCNC. That's plenty big enough for my purposes. Make sure the pipe cutter that you purchase is rated suitable for stainless steel. The very cheap ones are just for copper or composite. So that's 1, 2, 3, 4, 5 I've made. One more to go of the long bits. Then I've got to do the short bits. First of all, we assemble the 4 legs, which should look like that when they're finished. Like this. Get a screwdriver. Need to make 4 like that now. There you are, we've got all 4 done now. Make sure you've got 2 pairs mirrored. If they're all the same, you made a mistake in your printing and you'll have to go back to the printer. Make sure they're all exactly the same height and they are secured, each one's secured by 2 M4 nuts and bolts. But you might like to leave that until the final assembly when you can line everything up nicely. The next thing we do is offer up the tubes to the legs. Make sure that you've got all the corner pieces orientated the right way so that the belts fit correctly. There's no need to do anything else to this. It gives you an idea of the size and so on. We will put the fixings in later, but before we do that we'll go on to the next part of the build. So now for each of these, make sure that the letter here is lined up to make sure everything's pointing the right way. Stick the screws in, don't tighten them up. Make them all ready before we move on to the next stage. So I put 4 screws in there and 1 in there. Don't tighten them up yet. Do that for all 4. The next stage in the assembly is to put together the X and Y rollers. For that you'll need 28 bearings, you need 28 M8 bolts by 35 and a further 8 M8 bolts by 70, and this is how you put it together. You put 3 short M8 bolts through from the side opposite to the little lip. That's where the bearing's going to go. So we'll put those in quickly. You might have to ream them out a little bit so that the bolt goes in okay. I like to have it just a wee bit threaded. Keeps everything nice and snug. So stick those bolts through. And bearings go onto the little lip there on each of them. Then we get an M8 bolt and for the other side. Now those M8 bolts have to be tightened up just enough so that the bearing doesn't rattle about. So we'll tighten them up in a minute. The next thing we do is we get two M8 by 70. Get one of these little printed parts here. Put the bolts through from the opposite side to where the little lip is, because the lip's where the bearing is going to go. As that bolts in. That bolts in. A bearing. And then that goes in here. The round bit of that part matching up with the round bit there. Those go in. Again, I take a little bit of effort to get them in. Now the bearing goes in there. And the bolt goes through. Bearing goes in there. Bolt goes through. All the bolts are through now. All we need to do is put the lock nuts on, and the final operation is just to tighten them all up. Here's one I've done already. Need to do 4 of those. There you are, there's all 4 of the rollers done. You can thread them onto a tube just to make sure that they roll nicely. Things to look out for: make sure you think carefully before you stick every bolt and nut in, because if you get these little plastic bits around the wrong way, or if you put the long bolts in before you put the short bolts in, you're going to have to take it apart and do it again. Don't ask me how I know that, but the rule is put the short bolts in first, then the long bolts, and make sure that this bit of plastic here, the curve coincides with that curve there. Now to get down to the XYZ roller. These are the XYZ rollers. You need 8 bearings, 8 M8 bolts, 8 M8 nuts. The M8 bolts are 35mm long, and the 2 printed parts. I won't bore you by showing you how to mount the bearings, because it's exactly the same as the rollers that I've just done. I'll just show you the completed item. There you go, just tighten them as before. Just tighten them enough so that bearings don't rattle but still roll smoothly. Okay, we're doing quite well here because the last part has just come off my printer. That's the tool mount. This curve is slightly too wide for the tool that I'm considering using, so maybe I might have to redesign that, but never mind. So this, now we're going to start putting together the XY assembly and the central tool mount, the very complicated bit. So we're going to need these two big guys and loads of nuts and bolts and bearings. I'm just going to grab them as I need them. I'm not going to count them all out as I did before, because as you've probably noticed, I keep getting the numbers wrong. So we'll just grab them as we need them, as we make them. First thing we need to do with this is put 4 bearings in each piece, each XY piece. There, 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 there. I'll do that and show you what it looks like when I've finished. There you are, the 4 bearings are in, each one. You can tighten them up so that they are snug, not too tight so they start squashing the plastic. Now you need 2 M8 bolts, M8 by 45, 2 more bearings, 2 more nuts, and those bearings go in here, and we don't tighten them up because that's we're required to tighten them up later on when we're adjusting. And so make sure you put them in the right side. It's the side that's got the long connection, the long arm there, and there should be a letter. In my case it's a letter F, and yours might be a different letter depending on whether you're metric or whether you're doing this funny thing that they have over there, inches and stuff like that. Okay, so I'll do that. There you are, just leave those 2 loose. So this next bit's a little bit tricky, and so I'm going to film the whole thing and hope I don't make too many balls ups. So you'll need the, I think this is about 75mm long M8. No, it's more than that. It's 135, I think. Yeah, 135mm long M8 bolt. Get one of these XYZ pieces, and the indented end, put the bolt in the small hole. There's 2 holes there, put it in the small hole. Then there's a spacer, this black thing, put that through the small hole. Take the first of the XY pieces, and you'll see there's a little indentation there which gives you the orientation with the spacer. So that goes in there. But before we do that, we need to put a bearing in. So through the small hole, through the bearing, down it goes. Now that's got to line up with the outline marked on that piece. Next, we get the next piece, and that has the spacer outline marked on the outside, and we need to put another bearing in before we stick that in together. So put a bearing, short lines up through the small hole, said it was going to be fiddly. Fiddliest bit is getting the bearing lined up. There we go. In it goes. And we'll see that this piece is at right angle to that piece. That's because the two pipes have to be at right angles. Now we get another spacer. Stick that in the small hole there. And another XYZ piece. We stick that in there. Now, if we've done it right, all the holes the large holes should be lined up, so you should be able to stick. That bolt doesn't go there, but you should be able to stick it through just to make sure that it's all lined up. The other sides come drift, so I need to, there we go, all good. So that's all lined up, and there is now two additional bearings there and there, and all we've got to do now is offer up a bolt. Don't tighten it yet. You'll need to tighten it up when we've ascertained that everything is nicely at right angles. So that's as far as we've got now with the central assembly. Right, so we've reached this stage and there's a little bit of a pause while I do a little bit of a rethink. First of all, I've run out of M8 by 70 bolts. Don't know why I didn't order enough, but I need 3 more, so I've got to order those. And the other thing is I've been doing a bit of a browse around on Thingiverse and decided I really need to make me a nerdy-gurdy. But for some of the panels, this router is going to be too small. So I'm going to extend the Y-axis so that it becomes a 300 by 600 MPCNC. All I need is one more stainless steel pipe, and that's all I need to do. That's the beauty of this thing. You can just rearrange the size of it by changing the length of the pipes. I might print a couple more legs just to support the middle of the long axis. Apart from that, we should be good to go. So I'll order the bolts, and I also haven't ordered the T8 nut for the Z-axis screw, so I'll order that as well. And whilst I'm doing that, whilst I'm waiting for that to come in, we'll mount the stepper motors. According to the instructions, the next thing you need to do is to put the X and the Y axis tubing in there. Check that it's a right angle without dropping the right angle. As far as I can see, that's fine. And then the last thing you need to do is to tighten up the 2 bearings that we left floppy. That's this bearing here and that one there. So we can tighten those up, and that'll be this central part complete, apart from the Z axis for the spindle mount, which is what we'll do next. Now, the first thing to do with the Z-axis motor mount is to get a bunch of M4 bolts and stick them in the little holes there, which is easier said than done because they tend to try and go in sideways. So I find the easiest way is to stick them in with a pair of surgical forceps. They recommend on GitHub that you secure them with a drop of CA glue, which is maybe what I'll do. There you are. I got nice pretty shiny black bolts because they look better than the boring old silver ones. Here comes the CA. If you're a smoker, you can blow a bit of smoke on top of the CA, help it set quickly. I'm not, unfortunately, so I'll just have to wait. Now, I wondered what these things were when I printed them. Now I know. Apparently they're nut traps, and we need to do the same thing with our M4 bolts. Oh, I think I'll use silver ones, these ones, so as they stand out against the black, so that you can actually see them. And put a bit of CA in each one. As recommended. Whilst I'm doing this, I'm going to leave all the tools that I use on the table, so when I've completed the build you can see all the tools that I used, and that should give you an idea of what tools you need to build this particular machine. I think the instructions said all you need is a screwdriver or something, but I think that was a little bit optimistic. So now let's start assembling the Z axis. The first thing we need to do is stick a bearing into one of these things. They're different. And then we need to attach the Z axis stepper motor to the other one. And there are three screws. Those go in there. I won't bore you with showing you how to put a screw in. The only thing I've done different on this one is I've got a stepper motor with an integrated lead screw. It doesn't really say anywhere how long the lead screw should be, so I'm guessing it'd be about the same length as the Z axis pipes, so I might have to cut this lead screw off somewhere around there. I'm going to leave it for a while and wait until I see whether I actually have to do that. So I'll screw the stepper motor in, and then we'll mount the Z axis tubes. I don't suppose anybody's watching this because I'm just really making it as a build log for my own reference purposes, as I'm a senior citizen self-isolating. But just in case there's any Americans watching this and they're wondering what a Z-axis is, it's the Z-axis. There you go. I meant to say a senior citizen self-isolating with a very short memory, which is why I'm making this log. but I forgot to say that. My memory, see. Now before I carry on with the Z-axis, I need to drill holes in these tubes. So I'm just printing out a jig I got off Thingiverse to locate the holes accurately. Whilst I'm doing that, I will mount the 4 motors, which isn't a difficult job. Just got to screw them in, so I won't show you that. If you are going to print a jig to drill holes, make sure you print the right one for your 25mm. If you're using some other measurement, and make sure you print the right jig. Just for the record, I'm mounting these all the same way so that the wire comes out in the same place for all the mounts. If it's wrong, not convenient, then I'll just undo them and switch them around again. I haven't made up my mind where the wires need to go yet. This is the template to drill the holes in the Z-axis tubes. So it says top there, that goes to the top of the, towards the top, and the holes are drilled there and there. What I might do later, and I haven't made up my mind about that yet, is cut slightly longer Z-axis tubes so that they reach to the end of this screw thread. I've made up my mind I might either cut this short or make that longer. Don't know yet. Now I've drilled these 2 Z-axis rails, and we need this funny little bit of stuff which you were wondering what it was for. Well, that needs to get slid into the rail, get nice and square on to the holes, push it in. There we go, lined up with the holes, and stick M4 bolts into there. There we go. I've already done it for that one. Do it for this one. You better believe that you need a nice accurate pillar drill and an accurate template so that you've got those holes in exactly the right place. Just do the bolts up loosely before we move on to the next stage. So this is the tool mount mounted onto the Z-axis rails. It's quite a difficult operation and relies 100% on accurately drilling the holes. So you really need to print a template for that. It's not something that you're going to do by guesswork. Now we slide the lower Z mount bearing down onto the Z rails. You just separate the jaws a little bit with the screwdriver so that it slides down. It's not an easy job. Easier said than done. So that slides down. Hopefully. It's quite tight. Slide it down about halfway, and then we get the next one. Not looking forward to this because my screw thread's a bit long. Anyway, that goes on next, and that side on. It's going to take a little bit more swiggling around. I'll do that without the camera. As I say, not a straightforward job. There you are, that's done. Might have been easier if we'd done this job before we put the tool mount on. But it's done now, so we'll never know. The next thing you need to do is measure the distance between these two. I don't know what it is, I'll have to look it up and adjust them accordingly, and then tighten up the bolts to hold this in place. Well, in my case you can push it right up because I'm not using a coupler here. I hope the stepper motors got enough resistance against the thrust, because apparently they're using this bearing here as a thrust bearing. I don't need to do that, so no coupler for me, as I've got an integrated screw thread integrated with a stepper motor. Actually, I've had a little bit of a rethink about this. They say we should have a coupler there to couple the screw thread to the stepper motor. I don't actually need that, but they say it doubles as a thrust bearing. So I was thinking maybe if I drilled this out a bit, I could use it. I put it there and just use it as a thrust bearing. So I got this one out of my junk box. So I'll drill it out so it slides over the screw thread and use it as a thrust bearing. Also, I might make these rails a bit longer to match the length of my screw thread. I'll have a little bit more movement on the Z-axis then. Right, I slid the motor off. I've drilled out this coupler to 8mm, slid it over the screw thread, tighten it up, so now it's going to serve as the recommended thrust bearing, I hope. All seems good. Turns nice and smooth. The next job is to attach the motors, the X and Y axis motors, to the rollers. You need to put a nut in each of these recesses here, a captured nut, and just engage the M4 screw into the nut. Don't tighten it up yet, you can tighten it up once it's on the rail. So you do that with all 4 rollers. Now I'm going to put all 4 rollers, the X and Y rollers, onto the X and Y axis. I'm only going to do it fairly loosely because I'm going to put longer Y rails on here, but I'm still waiting for the stainless steel to come from Amazon. So on each of the axes we thread a roller. Make sure they all roll freely. And then we'll fix the corners before we put the movable gantry on. Just for reference, these are the tools that I've used for the job. Not very many. Few Allen keys, spanners for the M4, for the M8 nuts and bolts, a set of surgical forceps to get it to difficult to reach places, and of course a pair of calipers for checking measurements. I've sawed off the lead screw for the Z-axis stepper motor to length, and also don't forget the M8 T-bolt there for the T-nut for the Z-axis lead screw. Just tighten that up. No need to tighten it up very tightly because it's just going into the plastic and it's not going to take any strain anyway because the weight will be forcing it downwards. The bolts are just to stop it from corkscrewing. Actually, one bolt probably would have done the trick. There you are, all nice and snug. Now the Z-axis is ready to go in after I've put the final two roller bearings in there. I haven't got the nuts yet, the M8 nuts. As soon as they come from Amazon, I will complete that assembly. I've I mounted the spindle mounts on the middle assembly. I got them off Thingiverse for my particular spindle. Yours might vary. But what I did discover was, when I put everything together, I had 4 bits left over. So it's just as well I didn't tighten everything up. These bits, which are corner spacers, go in the corners, in each of the corners. How does that work? Like this. There we go. Before we tighten everything up. So just as well I remembered that. Now I've done most of the mechanics. I'm just waiting for the new rails. Thought I'd get started in with the electronics. So I've got this Duet 3D Mark III board, which I'm going to use, or at least try to use, and I've wired it up on the table. I made a little box with an emergency stop button to take the mains. I've got this slim power supply because it will fit nicely in the case I'm designing for these electronics. I've hooked up the Raspberry Pi to the main board and the screen. I haven't connected the stepper, the spinner driver yet. I'll do that when I've got the board working. Now I haven't switched it on yet. This is going to be the first time. So either we're going to see the magic smoke or it's going to burst into life. So let's give it a go. Press the green button. Whoops, something's flashing. Oh, there goes the screen. Yes, it all seems to have fired up. There we are, it's on the screen there. I've started casing up the electronics, but whilst I was doing that, the correct length stainless steel pipes have arrived, so the machine is now the size I want it, 300 by 600. So I'm going to tighten up all the bolts, all the nuts and bolts, the M4 nuts and bolts, so that the whole structure becomes rigid, and I will make sure it's all nice and square, right angled, and everything else like that. So all I need to do is start tightening up all the nuts and bolts and everything, and I won't bore you by showing you how I do that. And now I've tightened it up, bolted it down, made sure everything's nice and square before I've finally tightened the bolts. I make sure everything's square, and when you move it around, it's as sweet as you like. That's what we want. Next part of the job is to wire it all up to the electronics. Right, this is the latest stage of the build. I've connected the wires up, the wiring to all the stepper motors. The spindle, I've made the spindle disconnectable so that you can replace that with, you can remove it and replace it with another one, or with a laser, or whatever else, whatever other tool you wish to use. All the motors are wired. Some of the wires go through the pipes. I'm a little bit anxious about them being next to the stainless steel there, so I'm going to design some grommets to fit in the ends of the pipes to stop the wires, well, just to protect the wires really. Make sure that everything's wired up nice and tight. Nothing moves when the apparatus moves. What else have we done? Oh, we put the belts in, the belts for the X and Y axis. The arrangement on this particular design, I think it's been modified now for the new Primo, but it's rather Heath Robinson in as much as you've got to use cable ties to tighten the belts. I think I'll probably print some sort of adjustable end stop for that. The end stops are in. I've only put two, one for the X and the Y, just to give us a home position. For the actual home position, I'll design some sort of probe. The wires are protected by cable chain links, 3 of those, 2 20mm ones, the ones that are going to carry quite a few wires, and a 10mm one for the Z axis. I've designed a box for the power. A standard power lead just plugs in there, and there's an emergency stop button. Switch on the mains there, start and stop, emergency stop. There's also on the control box, which I've printed, designed and printed. On the side we've got the power supply, 24 volt power supply. I've used a slimline one so this doesn't take up a lot of room. There's the screen, a couple of fans to cool the underside of the board. They recommend you cool the underside of the board on the Duet 3D. There's a switch here to switch the spindle off and on, and a knob to adjust the speed. Now, this isn't bolted down yet because the last job I've got to do is to wire everything up, to put all the crimp connectors on the ends of these cables, which is my least favourite job. It's important when you bring these cables, because they all look similar, to label the ends of each one so that you know what they are. So this one here, for example, is the X end stop. That was the Y stop. This one's the X stepper motor, and so on. So my next job is to crimp the ends, cut these cables to the correct length and put the crimp connectors in. These are the wire protection grommets for the end of the rails. They're stainless steel pipes, and they retrofit. All you do is you slide it over the wires and pop it in. There you are, and that will protect the wires from chafing against the ends of the pipes. I used a proper pipe cutter and I've tried to deburr the ends, but you never know. There might still be a bit of sharp end there that might dig into the wire, go bang, magic smoke come out of the controller, and you're back to square one.